Okay. Okay, I want to make sure everybody's good. A couple things. Number one, is everybody good with the fact that D and F are identical? Okay, it does not matter the order in which it goes in. Okay, independent of that. Number two, you can do a couple different ways. I gave you one way. Another way would be to look at it as in, okay, these two are wired in series. So if you're wiring things in series, this would be 1 plus whatever that is. We don't know what that is, but this is the beautiful thing about algebra. You don't need to know. You just put it some variable. So that would be the total resistance of that. And then you take the blue plus the 6, and they're in parallel. So you would say 1 over the total resistance is equal to 1 over 6 plus 1 over whatever that was. Well, whatever that was, we don't know, but we do know the expression for that. And I told you what the total was. The total was 2. So you could solve for R with that. This is the same math, it just comes in from a different point of view. With that? Okay. All right, so this thing, thank you for those who redrew. It'll prove beneficial for not only troubleshooting if you missed it, but also for today's lesson. Okay? So here are popular wrong ways to do it and why they're wrong. Okay? Taking 4 plus 5 plus 1 and adding them in series. Don't do that because if you struggled with this, you should not be multitasking. Because if you take out this, that knocks out everything. If you take out this, that knocks out everything. You don't ever want to group things that affect things outside of the grouping. Okay? You don't want to group things that affect things outside of the grouping. Okay? So 1, that turns off 2 and 3. 2 turns off 1 and 3. 3 turns off 1 and 2. These affect each other and only each other. Like, okay, I've isolated that. Those are a group. Those are in series. Series are the easiest thing, in my opinion, to identify. Okay? You would, another popular wrong thing would be it's like, okay, 2 and 3, they're in parallel. If I take out 2, everything stays on. If I take out 3, everything stays on. But if you take out 2 and 3, that's going to affect what would that kill? I guess that doesn't kill anything. But if you take out 5, that affects 3, but it doesn't affect 2. So that's kind of your troubleshooting for like, I should leave the 2 for later. Okay. When you get here, we simplified this down to 6. If I take out 5, that takes out 3 and 6. If I take out 3, nothing else goes out. If I take out 6, nothing goes out. And if I take out 3 and 6, well, 5 goes out. But right here, the current has a choice at this junction. If the current has a choice, that's like a really big, like that's why things are in parallel. Okay. So, yeah. So you combine those in series, and then if you take out 2, that affects 5. 5 affects 2. Series. Sorry, parallel series, and then so on and so forth. You're trying to take little bites. That's the strategy. Okay with that? Okay. The other thing I want to point out is just because things are geometrically parallel doesn't mean they're necessarily in parallel circuits. Okay, like 7 and 8. Sorry. Yeah, those are in series wired wise. Good? So, this is step 1. We are now going to use what you learned to figure out the value measurements of an individual resistor in a combination circuit, and also looking at how trip-off rules are demonstrated. So here we've got, I want to know the current in this bulb. Okay. I'm going to say they all have 10 ohms. So we have 10 ohms here, 10 ohms here, 10 ohms here. Okay. I'm going to group these in parallel, and I'm going to redraw. So it gives me 1/5, so R is equal to 5. So we've got 10 ohms and 5 ohms. Good there? And then I'm going to wire these two in series. Add them straight up. Good? That is step 1. Just put your phones away. All right, now, once we get here, I want to find all 3 measurements, voltage, current, and resistance, for the resistor that I care about in each step. The redraw gives us steps to trace back. Tells me what I need to calculate where. Okay, this is essential. Okay. So I've got 15 ohms. I've got a 15-volt battery. So here I've got total voltage is equal to total current equal to times the total resistance. So I've got, there's a 15-volt gain here, there's a 15-volt drop across here. So we have 15 volts equals current times resistance. current is equal to 1 amp. Okay? Now, what I do with that is important. So, 15 came from 10 and 5 wired how? Series or parallel? Series. What measurement is the same in a series circuit? Current. This needs to be memorized. Very few things will tell you to memorize. This is one of them. In a series circuit, current is the same. In a parallel circuit, what's the same? Voltage. Those two factoids. You might be able to figure it out, but man, it'd be really nice if you just had that tucked away right there, ready. Okay? So, these two are wired in series. Current is the same in series. So, if there's 1 amp going through here, then that means there is 1 amp going through this one and 1 amp going through this one because they're in a series. Right? The current is the same because it's in the series. That makes sense? So I took a step back. I went and started here, and then okay, now at this point I need to find all three things of the resistor that I care about. Which of these two resistors do I care about? Where is the 2 light bulb buried in the 10 or in the 5? Buried in the 5. Does that make sense? So I need to find everything, all three of those things, for the 5 ohm resistor. Well, I know I've got 5 ohms, I've got 1 amp. So my voltage is 5 volts. So 5 volts across this guy. Good? Okay. The 5. So now, check, I've got that step. So I did this, found all 3, took a step, found all 3. Now, 5 came from the 10 and the 10 wired how? Parallel. What's the same in parallel? Voltage. So I can take the voltage across this guy and I can apply that across here and across here. So voltage is same in parallel. So I have 5 volts across this one and 5 volts across that one. How we doing? All right. Okay. So we're almost there. So 2, light bulb 2, 10 ohms, 5 volts. I'm looking for my current. So 5 volts, 10 ohms gives me 0.5 amps, half of an amp. Here's my answer. Okay. Granted, I gave you a simpler circuit. However, if you're faithful with these steps, you can take on any crazy circuit. Okay? Redraw the circuit. Every step you take, figure out, hey, I need to figure out the voltage, current, resistance for each resistor that I care about as you take a step back. Okay? If this one came from something in series, then current's the same. If this one comes from the combination of things in parallel, then voltage is the same. If you are faithful to follow those steps, you can take on any crazy circuit. Okay? Good with that?
That's another one.
Popular error. This is like by far the biggest blunder. You get here successfully. You get here successfully. And then for some unknown reason, actually I know the reason, you go from here and then you jump all the way back to here thinking you can apply this total to the individual. Crash and burn. This happens. Okay? The reason probably you did that is because you didn't redraw. Okay? So, these are the words that I just said. So if you're like on your worksheet this weekend, like, you can reference this. Okay. Real quick, just Kirchhoff's loop rule and junction rule, just to demonstrate this. I'm going to calculate this real fast. So this is 10 volts across this guy. So this is 10 volts here. And so if we looked at the loop rule, voltage gain equals voltage drop. You have 15 volt gain here, 10 volt drop, 5 volt drop. Okay. If you looked at this loop, 10 volt drop, 5 volt drop, 15 volt gain. Okay. This will always work. If it isn't working, you did something wrong. Junction rule at this junction. You have 1 amp going in here, and then here you have 0.5 amps, and this one you also have 0.5 amps. Current going in equals current going out. Proof of concept. And also we use a safety net. Okay. All right. Boil this one down to one resistor. Step one. Okay. How we doing? Get it? Okay. Those two are in series. So 6 ohms, 3 ohms, and 4 ohms. These three are in parallel. Four-thirds ohms. How do we do?
Pretty good. No.
Okay. So 1/6 plus 1/3 plus 1/4, 2 over 12 plus 4 over 12 plus 3 over 12 gives you 9 over 12, 3/4. Find the reciprocal. That. Okay. So that's step 1. Step 2. I told you there's 9 amps going through this from the battery, so there's 9 amps going through here. So I'm going to find all 3 things that I care about. So I have the current of 9 amps times 4/3 ohms. It's going to give me 12 volts. Okay. See if you can get back home. First find the current. Find the current going through the 5 ohm resistor. Or you need the voltage and the current for the 5 ohm resistor. See if you can get there before I get there.
Yeah. What? No, it's voltage. Yeah, the series stays the same, but it goes to the last step.
One thing, the voltage is the same.
We have to.
The other thing is if we the thing was like voltage is still
Series stays the current stays the same series. Yeah, and then voltage stays the same.
Not down to 6. Oh, isn't it just 9 times 12?
how would just how do you
What up?
calculate the answer?
What's the current from the 6 ohm resistor?
I'm gonna get 2.
Yep.
Okay.
Yeah. So 12 volts here. These are in parallel. So you have 12 volts here, 12 volts across here, and 12 volts across that. The one I care about is the 6. So I have 12 volts. Looking for current. We've got 6 ohms. So current is 2 amps. Since this is series, there's 2 amps flowing through this one and 2 amps flowing through that one. Yes?
No. I got it.
Okay? And so at this step, you have 2 amps, 5 ohms. So you have 10 volts. So the power then is current times voltage. For the individual ones, you have 2 amps times 10 volts, 20 watts. Good? Good.
How did you get 10?
Good question right here. So, are you good with 2 amps where that came from?
Yeah.
Okay. I've got 5 ohms. current, resistance, gives me voltage.
Well, like, why did you? Oh no, wait. Wait, why did?
Go ahead.
Confused.
Why didn't I do what?
So I thought it's 6. Why is it 5? Do you add them or do you just like not?
So right here, I dealt with the 6.
Uh-huh.
Okay, so I have 12 volts across this, and found my current with the 6 ohm resistor to be 2 amps. And then this one came from 1 and 5 wired in series. So I'm going to take my current, because it's in series, and that's 2 amps going through this one, 2 amps going through this one. I just care about this guy.
I get it.
Does that make sense?
Yeah.
Folks, if you're faithful to do these steps, redraw it, and then at every step do all 3 voltage, current, resistance for the resistor that you care about, you will get these problems right. So long as you do simple math right. Okay? Once you get these, people like in the past, students have been like, hey, I'm walking in. Like this is just this procedure. Like if I just carry this procedure out, I'll get the right answer. That's true. Okay? The thinking, the puzzle is this, getting here. But once you got that and you have the path that you got, you're just repeating this algorithm. You're like just repeating the series or the parallel. Okay? So I have printed out this worksheet.